So, hello. I hope everyone can hear me. Hello and welcome for day three of our rather crazy undertaking of writing an MMO from scratch with our bare hands. Um, okay, so let's see who is there. Okay, let's say hello. Hello there. Okay, let's jump right into it. It's already evening here in Europe, so let's let's get into doing some stuff. So, um, hello, pickled pocute. I hope I pronounced that right. Um, so let's jump into it. So yesterday we said, okay, how to continue best, and I had some thoughts about this. So how to really continue the most useful way, and I actually thought, okay, we will really continue kind of where we left off yesterday. I think that makes the most sense somehow. Um, and that is in the area of networking, but I want to get like even more concrete and let's say intensify the, the communication between the client and the server. But as is a bit of a tradition already, I want to start off with some initial thoughts and plannings of how we're going to do this. And of course, you're very welcome to give me some feedback in the chat if if you completely disagree on what I say, or if we should take a different direction for what we do today. I mean, that's perfectly fine. It's a live event, so we can be rather flexible. Um, but anyway, my plan is the following. So what I would like to do today is talk about some topics and then as quickly as possible jump into the live coding. But I think we should prepare some stuff beforehand. Um, so let's start. Let's stay free. Okay. Um, so today we want to discover more about the server and client interaction. How much from scratch is a scratch? Yeah, that's a good question. I mean, from scratch means, so I don't know if you followed the streams so far. I mean, what is from scratch? I mean, that's a good question. That's a very philosophical question. Actually, because from scratch could mean like, I don't know, we build our own computer and whatever. So this is not how far we go. From scratch means that we start with an empty directory where there is no code in, and then uh, we really build all the code ourselves. I mean, not like completely on assembler level or something. We use libraries. I think I mentioned that in the first in the first stream. So I'm not religious about like really doing every bit and byte by myself. But what I tend to do, or what I intend to do, is not to use any of the let's say big game engines, um, big frameworks like the Unreal Engine or something like that. I think it's a very good engine. Don't get me wrong, but it has not the learn effect that I'm after, or something like Unity. That's also a very good product. So we will not use something like that. What I will do and what I already use is a library, for example, like this here. So I'm quite a big fan of the SDL library, of the SDL framework. Um, so this is the SDLnet stuff, libsdl.org. Sorry. So this is this is actually a very nice library in my opinion, because it I think it hits a quite a sweet spot between um, helping you in some ways, like being like providing essentially rendering and some basic functionality that you need for cross-platform programming. So I mean, here you see what it does for you. It helps you with accelerated rendering. I mean, it helps you essentially, for example, to get a context for OpenGL under different operating systems. But that's very useful, and I think it's not so interesting. I mean, I did that quite often actually to create, for example, an OpenGL context from scratch by hand, just with the commands that you do under Windows. But that's not so interesting to do. I mean, it's also not so hard. I mean, that's just tedious. So this is where I think this is where I would draw the line, and this is where I use such a library. But when it comes to actually programming the game logic, that's where I would say we really do this from scratch. So, for example, we will eventually use an OpenGL context, but we will render all our stuff with OpenGL. Okay, we will very probably not write a software renderer. Only if everyone wants to do that. I mean, we could also do that, but that's maybe not what we're after. But to essentially program the game, the gameplay logic with our own means, and there we don't have any help. For when we say we want to program an MMO, okay, the network is a very big part of that. So what is from scratch there? From scratch there is for example, here we intend to use also this library, and as I mentioned in the last stream, this is essentially a very thin layer over the raw operating system sockets, and so it it does not really take away, I think, a lot of the elementary operation of how you do network programming. It just gives you some platform independence, which I think is nice, and it just gives you a little bit of convenience, so you don't have to think and you don't have to have rather nasty switch statements or switch macros where you say, okay, if I'm under Windows, I will use the WinSocket library. If I'm under Unix, I will use Berkeley sockets and so on. That's also not really very funny to do, but still, it's a thin layer. I think we still are very low level. I mean, we still send just bytes around essentially, and so we have all the fun and all the challenge and all the creativity and all the potential to really come up with a protocol, for example, from scratch. Okay, yeah, thanks. I will do that, yeah, because that's actually a good question. So that might really be interesting for many people. So what really means from scratch? So I will do that. I will not ramble around for that. But thanks for the question. I think it is a very good question indeed. Okay, so let's continue with what we want to do today. Um, and yeah, so today server client interaction. That's of course a very important part. So I want to dive a bit more into that. What are we doing here? And I want to make some concrete interaction also in the code where we will send some information, some packets. We will exchange some packets between the client and the server, which is something we did not do yesterday, but we will do that today. Uh, very, very much very much linked to that is the whole topic of how to handle the game state in my mind, because essentially that's a bit philosophical now, but if you boil it down to its essential, to what it is essentially, I mean that's all that is actually exchanged. It's game state in one form or the other, and it's like the authoritative game state that should live on the server, but more to that later. That is like always exchanged between the server and the client essentially, and the client has part of the game state that it wants to manipulate essentially, and it sends this information to the server. The server owns all the game state. It knows the complete truth of the whole game. And if it's an MMO, that's a lot to know. Essentially, that's a lot of variables that come into play. But that's really all. I mean, if you really boil it down to its raw essential thing, it's really you have the server in the middle. We have, in the case of an MMO, maybe on one machine it's hundreds or thousands. That really depends. I mean, it's not on one physical machine. Normally, you don't have tens of thousands of clients for several reasons. We'll also come to that. Let's say you have some hundreds or some thousands. That's already quite a lot. You have all these clients here, and essentially what you do all the time, you really just under quotes, you just exchange the current game state. So that's a good news. That's all we need to do essentially. The problem just lies in the details, because to do that in an efficient way, that's not so easy. Okay. Um, so we will talk about what game state is actually and how to represent it. There's different ways how to do that, how to partition it, and so on and so on. So that's two main topics of today that I want to delve into, and what what are the concrete coding goals for today is to send actually the client shall send a packet like a welcome packet, like I'm here, like I'm the client. So we will not do any login today or something like that. So, but just like the client connects and sends a specific message and saying, okay, I send like a magic byte or something like I'm here. I want to I want to take part in that game now. I want to be a part of it. Please send me maybe some initial information that I might need. And then the server will hopefully get that information. He will analyze what the client has sent to him, and he will recognize, okay, that's a specific message. So okay, that client tells me, okay, he wants to start, he wants to take part in a specific session. So I will send him part or all of the current game state. Um, and this is what we want to do. We want to do it in a simplified way. We want to do it in a more um, in a smaller way than we would normally do it. So it's a bit of a simplification on one hand. On the other hand, it's already quite the real thing. I mean, it's and this is anyway. I want to discuss this a bit later, more in detail. But this is anyway the philosophy of these first days here now. I I actually want to go with you now through the for the upcoming days, like through all the main parts of what an MMO is really about, in a simplified manner, like in a prototypical manner. So the code kind of looks a bit ugly and messy because I tend to use only one file, which might sound horrible, but it's on purpose now because I believe if I spend more time in right now just partitioning the code into many files and like doing it by the school book, I think it would just distract from what you want to achieve. And for now, for this first phase or this phase zero, that's not the main purpose. So we will just try to get as much prototypical features as quickly in so that we learn it together, that you can of course also react to it by questions and say, okay, Martin, sorry, it's just a prototype, but I still don't get it. I mean, why is the information going from here to there? How do you pack it into a byte? Why do you do it in that way? So the goal is that after not so much time, I mean, I cannot plan this fully because it's, yeah, I mean, it's life and we go from day to day, but I think that should not take much more than, I don't know, 10, 15, 20 days. Let's see how far we come. But that we together we really have a feeling, okay, well, the code as it is, I mean, that's not production ready or something, and that would not survive more than, I don't know, 100 clients or something. But in what it does, actually, it's the basic of what any any multiplayer game does, what any network game does. And to call it an MMO, then it's kind of just scaling it and saying, okay, well, it's not just for 64 players, but it's for, I don't know, 640 players, for example. And then we need to do other technical things to make that happen. But the essence of what we do, but shall essentially be the same. So like really in that phase zero, and I wanted to tell you that a bit that like what is the rough major plan of of what to do in the next days, weeks, months, I don't know, maybe years. Because to be completely open with you, I'm to really build a huge MMO, like with one person, okay, that's more or less taking, I don't know, a lifetime probably. So I hope you don't just leave now. But yeah, we'll just see. I mean, maybe someone wants to jump in and help anyway. Um, and even if not, that's not a problem. I have enough fun to do it by myself. But um, yeah, the scope of what we get in, I mean, that's just what we need to define. But it can take a long time. But at a certain point in time, that's not so much about getting much more complicated or getting structurally totally different. It's more like, okay, doing more of the same or just scaling it out a bit. But like what I want for us, for all of us, is to see rather soon, and this is should not take months or so. So that to see very soon, okay, oh, okay, actually that's the basic building blocks of what an MMO could be, and we just need to rough it out, and we just need to refine it. Okay, so okay, you no longer have much enthusiasm in developing in C++. Okay, I hope that's not because of my explanation, or so that's in general. I hope, or I guess. Um, yeah, but I share that. I mean, I'm also not having much enthusiasm in developing like really C++ in its, let's say, in its most intense incarnation. I'm more a fan of a style of C and C++, and I'm not religious about that. So yeah, I mean, actually, I enjoy to be honest, to work in C and C++. But yeah, let's see. I mean, maybe you get some enthusiasm back. Maybe you just enjoy watching some other guy stumbling about all the nice things of C and C++. So, okay, back to the phases. So we are in phase zero now, and then what I define as phase zero is really like finding our way. Um, that's really it. Being in a prototype phase. The prototype for me is like achieving almost all the main parts of functionality. I don't know, like 90% of functionality with, let's say, minimal effort. um, so this is really like what I try to explain. So this is really what we are now, and I expect this to take, I don't know, it's more in the terms of, I don't know. Let's say it's 1 month. Let's say it's 4 weeks. Maybe it's shorter. Maybe it's a bit longer. I don't know. But this should not take much longer. It also depends on how much I can do, how much time I find. Um, then in phase one, I want to actually do some more nice, let's say, software engineering practices, which you will not see in phase zero so much. It's more like coding stuff, making it work, but it's not really looking nice, and it's not really how you should really code. But it just proves that okay, that works. I can send that kind of data. I can do a compression that way. I can move my NPCs in that way, or I can send input information from the client to the server in this and that way, and that actually works. And then we just kind of take notes. Okay, what is not working perfectly? What would we need to stabilize? What would we need to improve on? And this we will do in phase one. So phase one is actually like the main phase where we'll do some real software engineering. We do the real implementation. At least we try to. Let's see if we can do it. Um, and and this is where I think we will spend like most of the time. And I honestly I cannot really plan this because that's very much also depending on the design that we employ. So how do we want to do this? And I would say we should aim for a pragmatic, realistic uh, design, like software design. So how do we lay out things? Which features, for example, of C++ do we want to use? Which do we not want to use? I'm not religious about these things. I don't think that that's so useful. Reality always shows that you need to be rather flexible, but we will have at least some guidelines, and I think that makes sense. So as you might know, I also share the code completely free and public on GitHub. So it's also useful, I think, if someone checks out the code and wants to play around with it, that he sees, okay, there are some guidelines, how the code is written and what things are done or should maybe not be done. That you get a bit into that. And if you are just a pure hobby programmer, that's perfectly fine, because then you might get a bit of a feeling of how these things could be done. Um, and then there is maybe a phase two. Let's see if we ever reach that. But let's be optimistic. Um, okay, I thought I have reached the end of Mischief, but no, I did not. That's really endless. I think we can go on forever. And in phase two, okay, there I would actually go into real optimization. Like when we say, okay, we are really kind of feature complete. I mean, we really have reached a state where we say, okay, that's actually working, and that's also in terms of how the software is engineered. That's that's nice. I mean, that's good. That's more than one person can understand it. That's like groups of people could work on it. That's nicely modularized. Okay, then, and I think only then we will really do optimization in certain areas when we have a certain stability, and we might then do some polishing. But yeah, as those names imply, well, that's really in the future. We're not there, for sure not in the next days. Um, so the bulk of work will be in phase one. Let's see if we make it. Let's see how far we come. This is where the rubber will hit the road. This is where things will get hard, even harder than they are. But let's see. We are now still in phase zero, and we have the freedom, or we take the freedom for ourselves to make it more in a prototype typical style. So, okay, I hope that makes sense. I thought it was a bit time to lay out what are my thoughts and plans for that in the longer term. Um, so does this mean that you're developing engine first instead of game first? That's again a very good question. So you already are in a very good position to win the prize for the best questions. I'm really thanks for that. It's really a good question. Um, I certainly have an opinion on that, and the answer is um, no. I'm not trying to develop the engine first, and I'm even going a step further. Um, I will probably, I mean, let's see how things turn out. I will probably not develop an engine at all, and I will tell you why. And so maybe that's a disappointment, but I will try to explain it. And why not an engine, or why not have it as the main goal? Um, engine. Let's say what are the plus and the minus. Okay, maybe we'll not do plus and minus, but just a quick answer from why not an engine. Um, So I'm programming since quite some time. I have to say I'm not a professional game programmer. I'm very open about that. I mean, I programmed a lot of games in my spare time. I'm a professional programmer in business software since more than 20 years. So I think I'm quite a solid programmer. I'm quite a solid coder. I've seen quite a lot of things, but I'm for sure not a game programmer. And the problem with an engine, under quotes, is I mean, it's general, it's generic, it's a cool piece of software. I programmed also some engines, more or less, half or three-thirds finished in the last years. And I don't think it's so nice to code an engine, actually. And also in my other coding, like professional business coding work, I made quite a transformation from, let's say, being a fan of very generic programming and programming everything like to be ready for each and every case, and like being super, yeah, generic, and being super adaptable, being super configurable at runtime and whatnot. I really changed my mind a bit in that, and I'm going into a direction that is more um, concrete, more to the point. So what you actually want to achieve, really code that. Don't code for any case that might happen. And that's even, I don't think if it's written that way, it's even a bit of a more naive coding style again, which one might like or not. I'm completely open about that. I just have seen so much engine and generic code that just theoretically can do anything, but in the end it does nothing really good. And I have seen quite some nice code, and I can, for example, very much recommend to study I think it's the Doom free code. It's open. It's on GitHub. So that's nothing illegal. It's open since a lot of time, and maybe you have already seen it. But this is, for example, a sweet spot. I mean, I don't have the. I mean, it would be nice to achieve something like that, but okay, I'm not as good to achieve something like that. I'm just quoting it because for me, when reading this kind of code, it hits a sweet spot between like having some generic engine elements and also, but being like very concrete and actually coding a game. Um, I mean, there is a lot of very cool stuff in there that's maybe much over all our heads. But this is like, it is generic, and it where it just makes sense, but it is not, I would say, I mean, it's called also the Doom Free engine, but it's not an engine like the Unreal Engine, for example, or even more like Unity. I mean, Unity is really like an engine. You can do almost anything with it. Oh, yeah, anything. Um, yeah, but I mean, it's good. Don't get me wrong. It's very good, but it's maybe not as good in a very specific thing like it could be. And I think especially for an MMO, um, it really makes sense to really code against what you really want to achieve. I don't know if that makes sense. So I don't get me wrong, I don't want to kind of hard code each and every piece, but I think it comes very natural when you do programming and and when you program on a bigger piece of software, in my opinion, um, it kind of comes very naturally, normally, to find out, okay, where can I generalize, where is a good chance now to do some generic stuff, and then where not. But no, I'm not trying to build an engine first. Okay, so what we want to do is really get to the point as quickly as possible. I hope that answered your question. Okay. Um, but let's see. Maybe some people would see it and say, "Ah, that's an engine." We will see. I mean, that's also a bit subjective. Okay, so like having all these boring generalities out of the way, let's get into more concrete stuff before actually coding. So let's talk about server client and the game state, and let's just quickly plan of what we want to do today. Um, so as we said, the server plays a central role. So yesterday we established that the server is the one that like collects information from all the clients and does something with it and distributes it then to the rest of the clients. And what we already said is that, okay, it might give some room for optimization, like the server sends to a specific client a slightly different information than to another client and so on. And that's especially interesting for an MMO, as we said. Um, because not every client might see the same things and might not be interested in the same things that just happen in the world. There's one more thing that you might have already heard of if you're interested in these kind of things, but I'm just remembering them because I'm still not quite sure like about the level of, I don't know, like interest or like history in game programming of my viewers. So please feel free to write it in the chat. And because if I'm just telling you boring stuff that you already know since 10 years, well, I can just skip it. It's no problem. But I think I tend to start like a bit more from the basics, and I hope that that's still interesting for you. Just let me know if it bores you to death, and we can skip it and just code right away. Um, okay, but going further here, there's one important thing, like the server. Even if there's a server, there is still an open question on how to organize what is the role of the server. I mean, what does it really need to do? Because the server could essentially be at least two things. I mean, the server could do like having like being really the authority, and nothing works without the server. So like the clients are really dumb. I mean, they do nothing at all in terms of bringing the game forward, actually, like changing the real game state. Okay, there's another question. I will just try to read it. What I'm asking is because you snug optimization and polishing, which is something that can only when lack of optimization and polish becomes a problem for a game, because it matters the most from the first time people can connect to the server. Yes, I agree. I agree. Yes. Um, I'm not sure completely how that connects to the engine question, but maybe you can explain me. I'm just not completely sure if I understand how that connects to the engine. I mean, I agree with what you say. I agree with what you say. I will just continue, but please, maybe you can refine, and I will try to answer immediately. Um, so first option for a server is to really be the only authority. So that means we have dumb clients. They merely connect input data like from the keyboard. They send it to the server. Then the server says, okay, well, let's see what you've got here. Let's see what you want to do. Okay, so you tell me you pressed the W key. So that means maybe your character wants to move forward. Well, nice, but I'm the server. I tell you, no way, you cannot do that because according to my information, you are in front of a wall and you cannot move anyway. Um, so this would be like a really dumb client. He just sent that information, somehow maybe waited for the server to tell him back, okay, what shall I do? And in the most extreme and bad case for the player, that's just you're making an MMO that you want to develop. I want to make a game that I want to play. Yes, sure. Um, and Yeah, both. But it's also an MMO that we want to develop. So the way is also the goal. I mean, to develop the MMO should also give us a learning experience. But yeah, it is a goal to have something that is playable in the end. It's not just some theoretical thing that you want to play, for sure. Sure not. It shall be playable, yes. And I would even go so far to sacrifice some clarity in code if necessary, but just to make it playable and to make it maybe performance optimized. So I'm not a super, especially for game development, um, clean code is important, but it's not like the end all be all. And if it reaches, so we will just do the thing that is necessary that our game runs and that we can play it, or someone else as well. So that's the philosophy. That's how I would like to go, as far as necessary, but not further. Um, I hope that that answers the question. Um, so that's the authoritative server. The other like extreme is like the dumb server. So it cannot be an authority at all. It is more or less like a pass through. I mean, it's like I don't know, like a proxy. It's just like okay, it, it, like it gets information so that the client just doesn't send okay there the user press W, he wants to move forward, but the client actually says okay, look, this is what happened. I'm player one. I just killed player two. I just I just shot a bullet. I just killed player two. Just to inform you, please tell all the other guys player two is now dead. Okay, that's the other extreme. And if I'm not right, that's more or less how the very first network games were actually done. And there is one obvious problem with that, and that is and that is and that is the cheating, and that is the cheating and the hacking of the clients. Okay, um, because code that executes, it runs on the server. I mean, also server can be hacked. I mean, of course, yeah. I mean, bad people can can break into a server and hack it. But let's say that's not the normal case. But what is almost a very common case is that code that runs on a machine of a consumer. Um, the code runs there. It's like rather vulnerable to be hacked, to be exploited. That if there is any, let's say, weakness in the way how the data is encrypted or not encrypted and whatnot. I mean, there is a yeah, people are very creative in hacking these clients, and as we all know, that's a big problem for many competitive multiplayer games. We all do it also for MMOs. Um, and it like if you're an MMO, the more power you give to a client, like, and with power I mean the more information that the client sends is like just taken as it is by the server and published to the rest of the players and like applied to the one and only game state. Well, that's really a problem because if clients are hacked, well, the cheating really like goes through until the heart of our game, and the heart of our game, and that's like the other topic that I have today, is that game state and what representation of game state we can have. So um, this is game state. Okay, we'll come to that in a second. But just to finish that other topic off, so the two roles of a server, these are the extreme roles, like super dumb client and super authoritative server, um, or like rather dumb server and like almost authoritative client. And what we will head for is more this direction here. So we will go more into the authoritative server direction. because I think that's the way to go. I think that's since long time already like the state of the art. It's you will see, or I believe it's actually harder to do. It really makes things a lot of easier in a lot of fields if you would have the other model. If you think about it, because well, the server code is just much easier. I mean, it just actually just takes what it gets and just applies the newest information to the state, maybe resolves a bit of conflicts. If one client says the other one is killed and the other one refuses, okay, maybe there must be some way, maybe first come, first serve, whatever. It's not so useful, probably. But these things are in general much easier, especially also for both parties. Essentially, it's for the client. The client doesn't have to deal with prediction and so on, and with the lag compensation, we will come to that. Um, and the server, yeah, it has less work to do somehow. I mean, it just takes what it gets, just applies it. It's rather done, but we are much more vulnerable to cheating. And even though maybe our MMO will not be the most the most successful in the world. It will not be a World of Warcraft killer, I guess. That would be unrealistic. But still, I mean, we don't want the game, even if it has only 5 players. I don't know. We don't want that someone cheats. So we will try to make it correct in that way. So so what is this thing that we need to secure, and what is this thing that is so precious that we don't want hackers to destroy our game? Because if someone cheats, I mean that's like in a board game. That just takes the fun out of everything. So what is it that we need to take care of? And what is the care? What is the core of every game essentially, and not just of a multiplayer game? That is the game state. And what the game state is essentially at any point in time, you can look at the game state. So like there is a time frame potentially. Oops. It goes from time 0, so that's like when the game starts, to like I don't know, like t end, like when the game ends. So if we now just forget a bit about a multiplayer game or an MMO for a second, let's say that's just a very simple single player game for a moment. I mean, of course, it has a game state, and if it's a very simple game, I don't know if it's something like Pac-Man. So, what is a game state in Pac-Man, for example? I mean, maybe I'm missing something out now. Don't throw stones at me, but like we have we have some ghosts. I think it's 4 ghosts. Is that right? With 4 ghosts, we have one Pac-Man. We have I don't know how many pills. Let's say we have 25 pills. I don't know, and we have 4 special pills. Okay, but that's still not really the game state. I mean, that's just an inventory of what we have. The real state is more than that, because that's at any point in time. And let's say I'm interested in this point in time. I don't know. That's like I don't know, 10 seconds into the game. If I if I want to know what is the state of the game, I mean that would not be enough. Let's say no ghost has been killed by Pac-Man. Pac-Man is alive. Okay, that's fine, but that's not enough. That's not enough if I'm a client, for example. If I want to render a Pac-Man game, if that's all the information I had, I mean, that would not be enough. So for each ghost, what we would need is at least the coordinates in the 2D universe. So that's like X and Y coordinates. So where is the ghost? That might not even be enough. It might be what is the speed it's traveling, and maybe what is the direction. So I think in Pac-Man you can only go north, south, west, east. So there is no diagonal movement, if I'm not mistaken. But um, so maybe you don't need a real like a vector, like where you would move, but you would somehow need to indicate in which direction that ghost is moving. So is it north, south, west, or east? I need to know that, um, and maybe also the speed. I mean, that could be hard coded. I mean, then you don't need it for each ghost, but you need it somewhere. I mean, you need to know what is the speed of the ghost in general, and I think the speed of Pac-Man can change, maybe also the speed of the ghosts. I mean, maybe I took a bad example. I'm not a Pac-Man expert, but I think, for example, Pac-Man, then that would be again the same thing. So where is it? Where do I need to draw the sprite on the screen? Where is Pac-Man? Um, and which, let's say, which speed state is in. So did he just eat one of those magic pills? Because then I give him a, I don't know, a by two speed boost or not, and so on. The 25 pills, okay, there it's more or less okay where they are. Could also hard code that. Um, but I mean, are they visible or not? That's maybe some decision I might have to take. And for the four special pills, the same thing. Okay, where are they and in which state they are in? Okay, so there's already some kind of information. But if you have that, then maybe I've even missed something. Yeah. What I completely did not tell you now here, but that's also a very important part, is like the game world, like the backdrop, like the in a 3D game, I would call it the terrain. Yeah, like the landscape. The game world, I mean, normally on average, that's rather static if it's not Minecraft, because then if it's Minecraft, you essentially have in a very efficient way, a state like the position and is it visible or not on for every for every cube essentially. But they store it in a very efficient way with voxel technology. But the game world, let's say, it's rather static, so it's a bit questionable if that's part of the, like, say, dynamic game set, that's actually changing, or if you want to say, well, the game world, I mean, okay, it has a certain characteristics, I don't know, it has a certain extent, it has made a width and a height in such a simple game like Pac-Man, and it has probably some information on how the labyrinth looks like. I mean, I think in Pac-Man it's completely static. Um, Drawing just some crap here. So you could really kind of hard code it and you don't have to even put it into your state. But I mean, you could. And especially, and of course, for an MMO, um, I mean, you have actually to take the same decision. I mean, I wanted to say, of course, you need to put it into the game state, but it depends. You could, for example, say, well, the game world or all my terrain stuff is actually divided into a dynamic part and, let's say, static parts. And static, that could be if you are not using voxels, then you can change the terrain. Um, if you don't do that, then you could say, I don't know, there is an area on that map that are some mountains, and and I mean they are completely static, like normally they are. You don't simulate earthquakes or something. Um, well, then okay, these mountains, they have a certain geometry, they have a certain layout, and that will just never change. Yeah, this is just what they are, and yeah, that's just the state of the game. It will never change. And why that happens, I will come to that. But then there is maybe dynamic parts, whatever. I cannot come up now with an example. But yeah, I mean, essentially, if you have something like Minecraft or in general some voxel-based world, well, then it's of course always important, if you are the server and if you own that world, you have to update your clients very regularly, very frequently, to tell them, okay, that this is the newest representation of how you should render the world. Okay. Um, so why is that interesting? And why is it interesting for an MMO and for the networking? Because it really makes a huge difference. So if you declare something static, then, for example, and I said we have this client-server interaction as a topic today, and that's a good example now. So if we say, for example, our world, our terrain is just completely static, well, then we can just either we just completely bake it in into the client, like in the patch client. That's what a lot of games do. Um, it's not part of the normal network traffic, but if it's a small world, we could say, okay, at T0 when the game starts, when a client arrives, client comes in, then the server sends it just the game world, the map, so to say, with all the geometry it needs, and that's fine. I mean, it will never change. That will only happen one time. It will only happen once and for all, and it might be a bigger download, might be on a separate thread, and the client stores the world, has it, okay, never update it again, doesn't affect the bandwidth. if you think about, okay, the world can change at any time. Any player can remove cubes. He can terraform essentially, probably. Um, well, then that's a different story. I mean, it's just not enough to send the game world once and to have it stored on the client. That's just not enough because it can and it will change probably very often. And then the problem is, okay, how can you how can you tell the client? So essentially, you have to tell it to him. And if you have a big world, okay, you will not be able to send all the data at once. Sorry. Um, so these are really important questions to take. And that's just also kind of a teaser of the kind of questions and of the of the nuts we have to break in our brains in the upcoming days and weeks when we really tackle an MMO. But we will actually not just start with the hardest thing right from the start. We will really make baby steps, and we will try to go from more safe ground. Let's say we will try to be sure that we understand that the very basics of like a static world, how we can exchange that, and that we have some dynamic elements like players, like other players. That's important, of course. Players move around probably, like NPCs that go around. All these things they are dynamic by nature, and we will concentrate on updating our clients with this real dynamic data. And you will see it's already a handful. There's already a lot of things going on with that, and that's what we concentrate on. Okay. Um, so coming back to what we will code now is like a very simple representation of game state. Um, and we will actually just see how we can exchange that between the client and the server. And we have some bit of interaction. As I said, client connects, server reacts, and then also sends something back. And yeah, I mean that's basically it. Let's see how fast we are with that, and then maybe we can go a step further, or we'll just see how it all fares. But that's already another like major step. If that works, it's actually just kind of refining it, but the basic thing is done then. Okay, so let's jump into coding. It's long enough already. So let's save that for later. Good. Let's go into coding. So we are in our wonderful MMO game directory, which is still quite small in terms of contents. So let's just have a quick look into there. Um, so there's actually now just two small files. One is the main. I would just move the chat a bit down so I can see better. Um, so we have the main CPP. That's actually the game client so far, and then we have the server main. And let's just open that up. So that's the client here, and we will enhance that client a bit now. So and let's also have a quick peek into the server maybe. So in the server, like yesterday, or maybe let's do a quick recap. I mean, let's maybe just start up the client once and then the server, so that we just see where we are, and then we see the difference at the end, hopefully. Um, so let's build. That's called the game. I'm sorry. Um, there is the exe. So that's the game. So if you remember, if you were there, that's what we built. That's our first game client. That's not very spectacular, I know. It's just essentially rendering the game time in milliseconds. That's what this does. And we will try to enhance it a bit today to make contact with the server. And the server, what are the magic tricks that the server can do so far? So there is obviously nothing rendered. That's just a headless server, but that's on purpose. I'll move that here. And what it can do, it is, oops, sorry for that. What was that? Um, it is it is actually listening to incoming UDP packets. And so as of now, we just have this packet sender as a helper tool to help us send some some data, and we'll just do that. So what it does, it essentially it um, receives the data, it reads it out, and it sends something back. Okay, so that's what it does. Um, Not much more now, but that's already something, and we will now expand on that. Okay, let me just quickly check something if you are on the right branch. Okay, yeah, that should work. Okay, good. So let's move back to the client. Let's enhance it. So let's say that the client, when it starts up, it connects to the server. Okay, um, and how to do that. So we know we use SDLNet, so we will need something from that library here, and I think that that's what it is. So without any change, we should already fail to compile, and I will tell you why in a second. So maybe you'll know it anyway. um, yeah. So whoops, it does not find the header, so we will just quickly add that. And we actually know already where that is, so we will just open up our build server.bat because that already has that. I will just copy it over essentially, and this is these two lines here. So this gives the path to the include into the library directory essentially, and we will move that to our build.batch file. And yeah, I think that was not so good. Let's do it like this. And yeah, I already know, and I will just do that right away. We also need to link to the SDL.NET library. So I will maybe not so much go into detail about these things. I mean, please just ask in the chat if something is not clear to you, then I will explain it right away. But I've gone through these steps in the other streams already, so I might bore people that have already seen this. So just let me know if you cannot follow, but otherwise I would just be more quick in these things now. So let's see if that builds now, and it does. Okay, but we just don't do a lot of things. So okay, we are in the client. That's fine. So we include SDLNet. So what we need to do, we actually need to set up the subsystem for SDLNet so that we can really use it, and you know it. And I will just do it. Where do I do it? Let's do it here. So here we have all the to have at least a bit of order in the chaos here. So here we have the TTF stuff, and here we do some net stuff. Um, so it's essentially the same principle. So I tried to do it now by heart. Let's see if I fail. Um, so we just give that command. If SDLNet init is smaller than 0, that's an error. Then we will just bail out, and I will just try now to use SQL log instead of printf. It's actually not a big difference, but I like it more, and it spares me to type the new line at the end of the at the end of the line. That's something. Okay, error while initializing SDLNet, and we will just ask it for an error if there is one, and we will just return one. We'll just bail out of the program if that doesn't work. Okay, it still compiles. It might sound ridiculous, but I really try to compile as often as possible. So the next thing we will need, I will also not go into super detail now, but we need a socket and we need a packet where we put data in or we can receive data. But let's do it step by step. So we will, I think it's called like this. We'll need a UDP socket. We call this our client socket. Socket. And we will just right away initialize it. And I think that's SDLNet UDP open. And there is one thing that you remember when you looked in the server that we gave the port of the server, because normally the port on the server that is known The clients need to know it. They need to connect to that server. Um, Whereas the clients, they don't need a known port, and it's okay to just say 0 here, and it will not, oops, that will not give it a code of 0, a port of 0, but that will just assign it a random port. Okay, because for the client, that's all we need. The client can have any free port that the operating system gives us, because it will initiate the communication. It will communicate to the server. It will connect to the server, and then the server, and we'll see how that works. The server will learn from the incoming packet what is the address and what is the port of that client, and then it will essentially know how to communicate back to that client, and it will learn the port just by the packet it receives. Okay, so um, let's just see if this is not a a pointer type. I'm not completely sure. Yeah, okay, no, that should be fine. That's essentially, I think that's more or less like a file handler, and it's just a, I think it's just an integer or something. So the next thing we will need is a UDP packet in SDLNet world. This is just the abstraction of the packet that goes over the wire, essentially. Or so we will call that our packet out, because we will just now really do it step by step, and the packet is actually a pointer, and I think it's SDLNet alloc packet, how to do that. And you just give it the size of the data that you want this packet to have, and we will just start now with 100 bytes. I mean, we will not use them now, but yeah, let's just start with something. And to be nice, we'll just check if the packet out creation failed for some reason, we are out of memory or whatever weird thing, we will just again bail out error while creating our outgoing package. And so we'll just return. Okay, that's fine. Good. Let's see if this still compiles. If I even saved. No, it does not. So what UPD socket? Okay, that's wrong. Where is that? Ah, yeah, okay. UDP. Okay, so that should work. Yeah, okay, it compiles. Let's also see if it still runs, because then we know that we actually created a packet. Okay, so that's that's a bit of a problem, because I'm spamming all this out. I will just get, whoops, I will just get rid of that now. Just a second. That's one of these nice printfs. So let's start the game again, because then it's not so noisy. And ticks per second. Okay, but yeah, so we reached our main loop, so that means we did not bail out because of an error. So it's actually okay. So we did not get in here because the packet obviously is all right. Okay. So in terms of the code, I mean, this is like really it's kind of ugly. I'm a bit embarrassed how it looks like, but it is what it is now. So we have this big main function here, and that's all like code that runs one time. Like, okay, the operating system calls us, we're here, we're doing all this initialization stuff. Now we also have a client socket ready, and we have a packet. And we do all other kinds of stuff, and then we enter like forever, like however long the game is running, we enter into our wonderful game loop. I called it frame loop for whatever reason. Um, And yeah, while we are at that, of course we will and we shall also send data to the server. But if you think about it, what we want to do now is we want to like connect to the server to ask for like initial data. And if you think about it, this is something that we want to do only once, essentially. So in our naive prototype phase, that's just why I will just put it outside of the loop. So we will just send some data to essentially, maybe we'll just write it down and then we just need to implement it, but we already know what to do. So send a magic byte package to the server. Um, Wait for the answer and like store the initial information we got and use it for rendering our world, our game. Okay, that's what we do. Um, Good. Connect to the server task for initial data. So connect. I have to put that onto, oops, sorry. I have to put that on the quotes because just let me know if I should go into detail for that. Otherwise, I would not now. You don't connect to a UDP server essentially. I mean, there is like not really something like a UDP server. I mean, you just technically you just decide who is a server, who is not. But like in UDP, everyone is like equal, and they just exchange packets, and no one is connected to no one essentially. If you want to have something like a connection, well, you have to program it yourself, and we will eventually do that. Well, not today, but so we don't connect, we just send a packet actually. It's all we do. That's all we do. This tells the server, hey, we are there. Okay. Like every client would do this. And if you think of an MMO, of a simplified MMO without login, well, clients come and go. And that's quite natural for an MMO. It's yeah, a bit different maybe for a lobby game. Yeah, you just come, you say, well, I'm here. Probably the server already knows you. He knows, okay, that client, I have some data stored for you in a database or something. I will give you the current date, the current state of the world, and I will give you also back your last state that I stored when you were last logged in. But that's all things we will do. For now, just send a packet. So to send a packet, we'll have that open. That's so also that you can see it. I think it's UDP send. Yeah, what else? Um, And yeah, I mean, if you remember, that's essentially the same code. You could even copy paste it. I just don't do it now from the server. Now, also, the server, if it sends a packet to the client, I mean, that's essentially just the same thing. There is no difference. That's equality in UDP land. That's everyone's the same, essentially. Okay, so SDL net UDP send. So it needs a socket. We have that. That's our client socket from above. It can have a channel. We don't use that for now. I don't say it's crap. I just don't use it for now. Just forget it. And then we need a packet, and that's our packet out. So the problem is if you do that now, what is in that packet out? Well, there's not a lot of things. Um, Essentially what we did, we told SDL, well, give us a packet out allocated for us in memory. That's what it did. That's what we also checked that it works at runtime, but it's empty. That packet is empty, and the packet is, where's the packet described? So the packet described here, and you see the packet is a struct, and it has a lot of data, and there is at least some pieces of information that we need to fill out so that SDLNet can make some sense when we ask it to send the packet. Because now, I mean, we can try it out. What happens? I think nothing will happen. And let's just see if it throws an error. I mean, I don't think so, but let's just see. It compiles. Let's run it. And yeah, I mean, it's fine. Okay, it sends out probably nothing. Doesn't even know where to send it because one piece of the packet information is actually the address. So this is essentially where to send the data. Um, And so we have to fill that out at least. Okay, so we have to say the address is essentially the address of our server, and we don't have that yet, but we'll do that now. And the address is of type IP address. So we have to form that, and let's call that the server address. Um, and that's essentially, I just look a bit up, just a second. So yes, so let's say that we have the server address here on the stack. And then there is a nice function in SDL net that says resolve host or something. Yep. So what it does, so you can give it the address of the memory address of an IP address object, and then you can just tell it like what it says. This is the host name or the IP in a string, and that's what we know. We know it's on 127.0.0.1 or on localhost, and we know the port number. And the nice thing, it will give us the correctly encoded IP address object, and that's what we need to pass into the packet. But that's just nice to do this. So we will do that now. It's resolve host. We'll give it the address of our server address struct variable here. And then we will say, well, let's connect to 121.0.1, and the port is 666. So just in case, if you're not sure, well, why do I know that, or why does he know the port now? In hell's sake, I mean that's here because this is how we set the server up. Okay, but this is where we say the server socket is essentially listening on port 666, and I know that it's on the same server. It's on the same host. It's on the local host. So that's why I know that. In reality, in a real game, when there's a real server somewhere in the world, probably, um, of course, you would not write that hard coded into the even if that would be a remote server address, you would not hard code it. That would be something that, for example, that comes from the patch client. So where is the gameplay server? And of course, also the patch client needs to know where to connect. So that is in some configuration normally. And that's, let's say the patch server is more or less hard coded. It's very stable because you need to start somewhere. But the gameplay servers, they are normally very dynamic and they can change even during a match. Probably one server goes down, you are moved to another server, and you just have to adapt as a client. That's all the nice things that happen. But now we know we are on the local host. Okay, so we have that address, so we can fill that out now, and we say the address of the packet which we want to send to is our server address. The next thing that we need to do, or that we want to do, is to put some data in the packet, obviously, because without data, it doesn't make sense. So what is data? Um, and let's just say, I mean, for today, I will kind of try to make this again like a bit repetitive and really explain the stuff. And maybe, I don't know, from tomorrow on, I will really maybe go much more quicker about these things. And if that already bores you to death, just let me know. I'm just doing it kind of slow now, kind of to be on the safe side. But if that's really too slow, just let me know. I can do it a bit quicker, not much, but a bit. So how does the data look like in that packet? I just have to find the packet. Let's just search for it. Um, Where to find the packets? Yeah, I think here we see the packets somewhere. Yeah, so that's what I was looking for. So that's an unsigned char, that's an unsigned indate. Um, this is the data, and yeah, that's actually similar from what we did in the on the server side. Let's just do it here so we are more local to what we do. So we just say essentially that's our data. And we can say, well, let's say it's 10 bytes. Yeah, it's just an array on the stack with 10 bytes, and let's call it our data out. And yeah, as yesterday, we can just this is the thing I like about network programming and doing this kind of little stuff. You really just on the like you really tell it each byte that you send over the line, and that's somehow nice. At least if you are like me, then you like this kind of stuff. So in that first byte of our data out array, we will now invent some magic byte, and we will say that's hexadecimal 7. Okay, and that's just an example of why this is a prototype. I mean, that's just not, yeah, it's just ridiculous. But one byte saying 7 and 7 meaning something, well, that's not how you would do it in real life. It would be much more sophisticated, very probably. But for now, it just serves the purpose. And for the rest of the data, we will now just leave it as it is. We just don't care. So there might be garbage in, but we just don't care for now. So what we actually do is we just give this variable here, because as you might know, the variable of an array is a constant pointer to the address of the first element. So that's just what we want. And the last important information is the length of the data that we want to transfer. So we could now say just transfer 1 because we just have one data, but just for just for probably for showing it to you, we will just now send out four bytes of data. And I think that should be it actually. We have the address, we have the data, we have the length. There is the max length that's not really interesting when we send the status. That is actually interesting, the packet status after sending. I mean, why not? Let's also fill that out. So that is something that we can read after we have tried to send actually. So let's make an integer variable, and let's call it sending status. And yeah, I mean, let's just set that to 0. So if it still is 0 afterwards, well, then that's a problem, because if we have sent 0 bytes, but we wanted to send 4 bytes, well, that would be a problem. So that's not what we wanted to do. And then we just say packet out status is the, I think it is the address of our status. Okay, no, we don't have to get that, but the packet after we have sent it, we can just read it out. Okay, sorry, that was an error. I think I've never used that. Shame on me. Okay, so we should have everything now. We will just we'll just send that now. Essentially, oops, we will just put that down, and we will now send that out. Okay, so that should work. I mean, let's just compile and run it. Even if the server is not running, that will just go into Nirvana essentially. But let's just try that anyway. Does it build? Yes, it does. Does it run? Yeah, it runs. I mean, it just does not crash. That's good. Let's actually see. I'm interested in how the status looks like. Can you please add microtransactions? Yes, for sure. We will do that. Yes, for sure. You mean in the MMO, of course. That will be the main goal. So I don't know. I mean, or if you're interested in how to do that from a technical point of view, yes. I mean, we can definitely do that. I mean, that's interesting. I think that's not so hard if you plan from the beginning. Um, if it was not completely serious, okay, it is also fine. Then I'm not a big fan personally of microtransactions when I'm a consumer. So but maybe if we are on the other side, if you do the game ourselves, we might just do it. Okay, so let's now see what is the status actually. Let's just print that out. I'm interested in what that is. I assume it's 0 because there was no server. It couldn't really send it. But I mean, let's see. I mean, it will just anyway it's UDP, so it will just give it to the network card. And yeah, I mean, let's see. I'm interested. Status of our last send. And that is then the packet out status. And let's just see what it tells us. Let's see what that is. Okay, yeah, that's what I expected actually. I mean, and that's already a good example. So we see that's one of the nice things under quotes of FUDP. I mean, it just told us we sent out 4 bytes. Um, so if and that's really actually a very good example of the like the problematic nature of UDP from a point of view, because you just don't have any information now that, well, for sure the server did not get it, because I know it because the server is not running. It's definitely not running. But from the point of UDP, well, it gave it to the network controller and it just said, well, here are the 4 bytes. And yeah, just sent them on the way. This is the address. This is the port. I mean, I don't even know how many hops this is away, if this goes to the end of the world or not. Um, and from a like local standpoint, well, it was sent. It was sent. It's like if you send away a letter. I mean, you put it into the post box, and maybe it was even picked up by the postman. That you can see. But yeah, that's all. And this is the state where we are in here now. This is like, okay, the postman picked it up, um, or it seems like he picked it up, but we just don't have any knowledge or guarantee that we'll ever receive the target. Okay, but that's what's UDP about. The good thing is it's quick because it's so light and it's so unintelligent in a way. Okay, so now let's switch sides. So now let's assume we are able to send something out. Now let's switch sides to the server, and the server now we need to enhance that a bit now. Or actually, I mean, not so much, because if you remember, we already. I mean, let's try just something out. Let's try just out, and now is the time for the first time that we will have a second command prompt here. And now we are like really entering multiplayer multiplayer world. So we will have now one process running as the client and one process running as the server on the same machine. But yeah, that's what it does. So let's first start the server, because like the server must be there before the client comes up. So let's go into our wonderful small project here, not into the recycle bin. And let's just run the server as it is now, as you know it from server game, I think it's, as you know it from yesterday, starting up, listening to incoming UDP packets. Okay, so let's now run the client, and if all goes well and that didn't fuck up, then it should actually receive something. And I think we are already good. Yeah. So let's have it run, because that's like what it would be in real life. So the server was there before the client. So that's like, okay, that's like a law in nature. That must be. If the server is not there, well, the client is screwed. But the server was there. The server is there. It's running. It's waiting for clients to connect. Then the first client came up, and what it does, it sends some information. And so we'll just put that out of the way completely now. In that moment, so we are in that server also has a loop. It also has a kind of a game loop, or it has a game loop essentially, where it always checks if some packet is on the network. And yesterday, you remember, we sent ourselves a packet via the packet sender tool, this nice tool, and I told you this actually serves like a substitution for a real client. And now we start to have a real client. And so yesterday we used the packet sender. Today, for the first time, we used our own client. And the client sent a very primitive packet with a special byte. And if you remember what we sent a magic 7 here. This is where we did it. So hexadecimal 7 and decimal 7 is actually the same, so it doesn't matter. So wouldn't need it, but I don't know. Just every time I poke bytes into an array, I tend to use hexadecimal numbers. I don't know why really, but I do. So this is where we poked it in. This is how we sent it out. So we have it in that array. This array we told, well, that's for you packet. That's the data. Please use the data that's in on that spot. And then it ended up here. The receive was okay in that moment, so we received something. This is printed out. The game server received something. That's interesting. You received something. Okay, that's interesting. It looks like a different version. Whatever. Um, Good. And yeah, the data received, and it really looks. I mean, I played around on a different branch. It looks like somehow that is messed up. I mean, I really have to look. Ah, I know the reason. Haha, I know the reason. Okay, so let's. But anyway, forget it. I will clear it up in a second. What is going on? I know it because I still have the binary of some stuff I played around with the on a branch of that code actually, and there I have played around with different ways of printing out the port. So I was just confused. That's why there is a different, and that's why. So it's actually a different binary, but I will compile it from scratch and I will show it to you again. But it doesn't matter. So we receive the packet, data comes in, and we just print stuff out. Okay. So let's just close down the client for now. Let's also close down the server and let's rebuild the server for now. And let's just do that again very quickly. Pop. So, and we just do it and it still works, but now it's like completely in sync with the code that is here. And so like the game server received a packet, so we're not cheating. It's this code, so it came in here. And actually the data received is 0 now. And why is that 0? Yeah, I can tell you. So I don't know, it's a quiz. So who knows why that is 0 now? Or why it's not 7? Why is it not 7? So I don't know. If someone wants to tell me, it's fine. Otherwise, I would just I would just resolve it. Because here, when we say which data we received in that data in package, we actually go to the index 1. Okay, so that's the second cell of that array, so to say. And what we want to do is we want to look into the first cell, and then that should show us the 7. So I will probably, oops, sorry, probably move that a bit because I think because of the chat you cannot see it so easily. So now run again. Yeah, and there you see the client came up. We sent the magic byte. I will close it down. And now the server received the number 7 here. Okay. So now it's quite easy. It's really now the next thing we need to do. We just will, yeah, like in a real implementation, we now do something with the data. Yes, that's right. So let's go a bit more in that direction already. Okay. We're still not doing super sophisticated stuff, but a bit. So let's say we want to, so like this is the server, it listens for any packets that come in. At that moment in time, we don't really know what the client sends us. I mean, it can even send us, I don't know, harmful stuff. We don't really know. So we should really kind of parse what the client sends us. And this parsing of what the client sends us, yeah, you can make it more simple or you can make it very complicated. And that really depends on, of course, what what you are receiving, and then what is your protocol essentially. What do you expect? So normally you are not completely in the dark. So just to oops to show that a bit before we do some very simple parsing now. And why I highlight this, or why I go onto the whiteboard again, is because that's also one of these like main essential parts. And we will do it now in a super simple way, like almost ridiculously simple. And but it is the essence of it. Again, this is already what's going on, maybe on a slightly different spot. And a bit more sophisticated, but that's just what's going on. So what is happening? The client sends out a packet to the server, and this packet. So what we did now, I think it was actually we sent out 4 bytes, but let's just look at yeah, let's say these are 4 bytes. And what we essentially did is we said in the first byte there's a 7, and we didn't care about this in the rest. So very probably there is a 0 in it, and we should actually clear that out and make sure there is a 0 if we want to be on the safe side, because otherwise we could completely confuse the server. But this is what we send out. It's actually only 4 bytes. Um, and yeah, that's of course like super simple, and that's not enough information in the real world. But in a real scenario, and as I said yesterday, we might even encode 1 byte with the specific bits, but we might send all kinds of numbers here, like just decimal numbers now, or like whatever, I don't know, like AB, all kinds of numbers essentially. Um, and this just has to make sense to the server. So how does this make sense to the server? Of course, because there is a protocol that you have agreed on. And I mean, as the writer of that MMO, I mean, we invented protocol and we will eventually make it together. Um, so the parsing is actually, it's not like parsing a language or something. It's actually much simpler than that. It's just there is not so much options that you have normally, and there is yeah just some tricks that you can do. And normally you just start like a hierarchy. So when you have the first byte probably indicates like what we could call a message type. Okay. Um, so if I say the first byte encodes the message type, that means, okay, we can have 255 different message types. Okay. Because a byte has 256 different message types. Sorry. So from zero including to 255. Um, and that's already something. And that's just an example of how efficient you could do things, because you say, okay, maybe you just need half a byte. But let's say, okay, we have thought about this. We know that we need, I don't know, roughly 240. Well, then we will just either we will just do a byte, or we will even say, well, we could probably, I mean, I did not do the math now, but maybe we could do with 6 or 7 bits. And yeah, that can make a difference. But now let's say, okay, we just say that the first byte is the message type. Then, okay, the server, what it just needs to do, and that's very simple, um, and I will show you, is to just read that first byte, analyze it, and say, okay, that's number 120. And like on the server, I have something maybe like a map, like a lookup table or something that says, let's say 120. Oh, okay, that's the that's that's input data. So this gives me input data. So when this is 120, then I know the next byte, and let's just say that the next thing is a byte that we examine. Then the next byte is, and that's kind of completely ridiculously inefficient, but let's say the next byte after that, so this byte here, this tells me the state of the oops, of the forward key. So I'm not saying W or something, because that might be mapped essentially. I mean, you know that from games, because one guy uses W and the other one uses something else. So you want to know the logical forward key, the state of the forward key, and you say, well, it's if that byte is 1, it's pressed. If that byte is not 1, anything else, then it's not pressed. Okay, for example. But there you see, and we will maybe just start out with these kind of inefficient but very simple protocols, and we will just do that. And so that's it. And then you would know maybe the third byte, that's the right key, that's the state of the right key, and so on and so on. And if that's a 1, then it's pressed. And I think you already get the hang of it. And that's it. And then it's just like, how much bandwidth do you want to spend? And this is it. Okay. I hope that makes sense. And now let's parse, because parse is a big word, but we there's really not so much about it. It's much easier to parse than if you invent a language, really. Um, I wouldn't even call it parsing in a way. Which is like structure reading the information. So let's just continue with that example, and let's say we call it the message type. And we know, because we are the programmers of the clients and the servers, that's why we know it, why we are the inventors of all this crap. The message type is in um, data in index 0, like that's the first byte. And then we might do a switch case, or we might just do if then else. I mean, let's do switch, because that's more like a bit resembling the reality then. So we make a switch over the message type, and we have different cases. And let's for now say, like, if it's 0, whatever, um, then let's do just a print out of let's just say that's a logout message. Let's just invent that. Like, if someone sends a 0 in the first byte, that indicates I'm leaving the game. Okay, that's a logout message. And then what we would do is kind of remove the player from the game, from the current session. Okay, um, and so on and so on, and do all the things that are necessary. And finally save its last state into our database, because we might not know when he logs back in, maybe in 1 week, but then the player of course expects that all his latest state is there. I mean, all his stats are still there, all the weapons are still there, all the quests that he has done, the game still knows that they are done, and so on and so on. So we might do all kind of bookkeeping and storing the state to the database, for example. We will also do that before, obviously, but at least also do it when when the player logs up. Um, yeah, and that's it. We're not doing now for more. But and then let's say we skip other things, and then let's say if the case is 7, okay? Then we will see, okay, this is a this is a let's call it now a login message. I know it's not a real login, but let's pretend that's our login. Um, And what we'll do now, and let's just use a function, and just not write everything there. Um, Send initial data to client. And what we will pass to this message to this function is, or to this method procedure. It's not a real function. It won't give back anything. Um, we will tell it. Let me think of what it needs, but it will need essentially the address of the client. Okay, and where is the address? You know it, it's in the packet in the address member. So we have our packet in, and we have that address member. Okay, so that will now not compile because we don't have that number, but I will just compile it anyway. Let's close down the server because it heats up my computer in that endless loop here. Um, so actually, that's a server. Let's build the server. And yeah, I mean, this is just not there. And let's just copy that, and you see how crappy and messy our code is. We just have to go to the top, um, and that's a void function. And yeah, what we will do now is, and we will, I mean, that's wrong, because whoops, that is a UDP packet essentially. Sorry, that's an IP address. Sorry. Um, the address, that's the client address. Oops. That's the client address that we got here. Um, so what we would do now here, and yeah, let's just do that the naive way. I mean, we could reuse a packet that we already have allocated before, and we could pass it in and all this kind of stuff, but that's just the thing that I will not do here now, because I think it makes it a bit harder to understand if we use a packet from somewhere else. Um, I hope you agree. Um, Yeah, first function. I mean, it's a second function technically after main, but yeah, I I stuffed everything in main. A very bad practice. I know. I'm embarrassed. Um, so we will now just do the thing that we always did. We will allocate a packet, and this is like our out packet here. And I think this just alloc packets. And let's say we know now that our state, that our initial state we want to send to the client is not more than 50 bytes. So that's just all we want to reserve. And yeah, just as an aside, so you can already imagine if you have a huge world, well, that will not fit into one uh, into one UDP packet for sure, or very likely. So that's another nice thing that you have to do. You have to think and how to split your data into certain packets and so on. That's all nice stuff that we will do a bit later, but just so that you are already depressed that we have to do this. Okay, so we have the packet. We will again stuff data into it. Um, and yeah, let's just do that in the normal way already. I mean, we are super how do you say? We have a lot of routine already already with that. That's our data out, and that's let's make it 50 bytes to be coherent. And let's just say in the first position we give it, um, let's say, and I will comment it because then it's in GitHub and then it's easier to read. Um, so index 0, that's, let's say that's the x coordinate of, of I don't know, let's say of the player itself, okay? Of the player itself. So for that specific player. Then 1 will be the y coordinate of the player itself. Then I try to make this now a bit semi-realistic, but not too much. Like then you could say then in the third byte in the index number 2, um, that's it could be, for example, because you work like in different layers and you work normally hierarchical, so you probably don't put all the data right away, but you just give indications of how much data comes, and so maybe the client will even ask it in a second request, or at least what you have to do, um, if that's always the case if you transfer data to Summer. If the if the number of data items is kind of dynamic and it's not hard coded, then you have to indicate it. That's a number of, for example, the number of players online, and so that the client will know, okay, if here on that in that position in the byte in the array I get a 15, for example, then okay, I have to read the next 15 uh, bytes, or the next 15 multiplied by 2 bytes will be the positions of the 15 players that are actually currently logged in and that you probably need to render. So, but that's dynamic. That can happen. In 2 minutes later, it could be only 13 players, and 2 hours later, it could be 150 players. So this is where we will indicate the number of players and their positions, and then starting, let's say that's really our protocol. From 3, that's the y, that's the x coordinate of other players, not yourself, other player number 1, and so on and so on. I mean, I think you get the idea. Well, we'll just stuff some data into that now, but that just gives you an idea how you build that up. And yeah, for example, so you might say, yeah, that's not a good design. I mean, the player itself, that's just a generalization of um, that's just a generalization of the players itself, and we could just say that's a number of players, and just the first position is just you. Okay, we could do that. Um, the question from Pickled was, are you planning on using any scripting? Yes, indeed, I do. So I did a stream actually some days ago, like my first stream ever in my life. That's my third or fourth stream ever in my life actually. So I did my first stream with playing around with implementing a small virtual machine. Very primitive, and it was just like a vehicle for streaming. But yeah, I want to do that, and I'm not completely sure if we will integrate some language like Lua or Python. I did that in the past already. It's quite fun. It's nice, but it's also super fun to integrate your own scripting language. And there it's a fine line between it's just fun, but it's maybe not so useful to do. But let's see. I mean, let's also see what the other viewers think. I would like to use my own scripting language, kind of. I think that's ridiculously funny to do, and that really gives a lot of satisfaction if you do that. And yeah, but we will do that very, 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 very probably, and maybe even quite soon, because that's really fun. That's really actually one of the most fun parts of writing a game, um, in my opinion. So yeah, that we will do. Okay, so for data out, let's say the x coordinate of player itself. Um, let's just say I'm the server. I know the player. That's where it last time it was sitting down and logging out, and that was in my world. That's world coordinates. That's 15 on the x. And for now, we will just be in 2D world. We will go 3D, but for now, let's just say we are in 2D. So what does that mean? 50, 100, X, Y. This is where the player is. So if I'm the client, if I get this kind of data, I I get actually two informations with that. For example, that's yeah, just as an example, one thing where you don't. That's like an implicit um, information because just by sending the X and Y coordinates of the player itself, the client knows where it is situated in the world, and thereby it knows which which other things are interested and are interesting to render, and it has a certain render horizon and so on, like a minimum and maximum render distance and so on. So yeah, I mean that this you can put some information just with this, and of course in reality we would do some other put some other data in here, like the number of players. Let's just make it real now. Let's say there is two other players now. So what does that mean? So we have to say data out. So that's the first player now. That's the X of the first player, and he's at 55, like standing next to me, like right to me. And sorry, that was a bit too um, that was a bit too optimistic. Um, and let's just say um, so I'm already quite tired. um, and he's also standing at the same white position, but just a bit left, right to me. Um, Then the other guy is completely somewhere else. He's like 150 and 135, and he is at, I don't know, 155. And the other guy, the X coordinate is 88, and the Y coordinate is boop, 90, whatever. Okay, so I think you should get the point. I hope that makes sense. This is now the data. Did I mix everything? No, that's fine. So we'll just let it point to data out. Then you know the drill. Out packet. Pop. Len. So that's now 9. Yeah, 0 to 8. That's 9 bytes. That's what we tend to send out. That's what we intend to send out. The address, we have that because that's a parameter of that wonderful procedure. The address is the so-called client address. So that should be actually it. But I think it's actually like that. I just don't want to scroll down now. And but yeah, it's already late, so I have to. No, that's the wrong thing. Um, send. Where are we? Send. Sending out. No, send. Yes, that's what I was looking for. So yeah, we have the sockets. No, sorry, that's not UDP send. Wrong thing. So that's UDP send. Yeah, so we have the socket. Should know that already. That's our server socket. And now we have a bit of a problem, and now we will do some nasty thing. Oh my God, we will make a global variable. I mean, we could also pass it in. I mean, why not? Let's make it at least a bit cleaner. Let's not make a global variable now, because I think Pickled would complain, and rightfully so. Um, um, let's pass it in. So that's a UDP socket. That's more or less an integer handle anyway. Let's call it the server socket. So because we're in another scope here in that method, and so the server socket, we created that here, so that obviously lives only in the scope of that function, and we cannot see it there. So we need to put it where? Here. We need to put it as a parameter here. So we will pass the server socket to that function, and that function just doesn't care. It will just use the socket that is given here, and it just assumes that's the right one. Then I think there was the channel. Yeah, we just skipped that, as is the tradition, and the packet, and that's of course our packet out. Okay. Um, okay. I mean, let's actually try this out. So to make it useful, we need to right away. I mean, let's just try if it compiles. That's always necessary, in my opinion. Wow. Okay, we have a bunch of errors. Okay. Um, that's interesting. Why doesn't that work? Um, what does it say? So that's the beauty of live coding. Pack it out. Yeah, I mean, let's. It's late. Let's do the the easy things first. Packet out is in fact out packet. Okay. Um, and let's motivate ourselves and get rid of that. Um, so what is that? Why is that? Why is that a problem now? Yeah, I mean that's also a problem because I just messed this up. So you see, it's definitely live. Okay, we're getting there. Um, I mean, I just might have misspelled this. I tried to be cool, but just did not work. I think, yeah, that's because of that. And let's just see, because sometimes when you have an error more up in the stack, then there are other crazy errors that just then vanish when you do it. Um, data out. Okay, yeah. Oops, I see. I mean, I made a pointer to pointer actually here. That's not necessary. So if that's an array, if that's a static array, that's already a pointer. And I think that was the problem here. I'm quite sure. Yeah, almost. I mean, at least these kind of errors are gone. What does it tell me? Invalid conversion from int to UDP socket. Okay, that's something else. Chip chip chip. UPD socket. Yeah, okay. Because again, I did it. I did it. I did it again. That's just not my word here. Okay, we are compiling. Let's just see if it basically runs. I mean, there will not happen anything, but okay, at least it looks like it's still running. Okay, so now we are the server, and we are sending some initial data if we get a very specific message from the client. So let's move back now to the client. Oops, not here. Let's move back to the client and let's enhance that a bit. So um, let's say, let's first start naively, and that might not work. That might be a race condition, but I will come to that, and then let's maybe improve it. Let's make it step by step again. Um, so the naive thing is, now what we did here in these lines is essentially we contacted the server. We sent something to the server, and we tried our best. We know We are not hacked. We are not a hacked client. We are a good client. We know that in the first byte of what we send of our first message, there must be 7 because that's the login message. That's the message where we get initial data, which we need because we need to render it. We are the game client. So we send it to the server, and now my keyboard is broken. Okay. Now, next, we wait for an answer. Okay. And the waiting will come. We will now just again have a UDP packet, now correctly written. And that is our, yeah, it's just our packet in. I mean, it doesn't matter. Now, I think I know how it's written. I think I lock packets. And let's say we know, or the configuration gave it to us, or the patch client told us when it started the game client, for example, that look, the initial size of the data is 50 bytes. Okay, that's that's how it is, and that might be different in 1 week, but now it's 50 bytes. So that's why we allocate this. That's why we know it. Now it's hard coded. In reality, I'm sorry, that was maybe loud. Um, in reality, this is not hard coded, but here it is, just for prototyping sake. Okay, this is our packet. We know for an incoming packet how this has to look like. I mean, I just look it up really now. The incoming packets, I think they are quite lightweight. Yeah, you just do them and then you just use it. They are nice. I like those incoming packets. I mean, they are nice to use. Um, so we have that packet, and then we just essentially say UDP receive. I always forget these these things how they are really called. Um, is it UDP receive? I think something like that. Yes. Okay. Yeah, it's UDP receive. Okay. Wow. What was that? So I think it's time that that I close down. I think I'm already making too much crap, more than normal. So we are using our client socket that did not change, and we are using our packet in. That's already a pointer, so we don't need the address here. Um, so we received that, and the next thing, you already know that, we now examine the data. So we will just prepare it now, uIndate. Oops. That's the data in. I mean, that is the initial data. That's what we expect. Like the initial data is coming in, and that's the packet in, and that's the data member. Okay. And now we examine the incoming data, and essentially we're also kind of parsing it. I mean, it's really like always you see it's two sides of a mirror. Like the client and the server, they do very similar things essentially. It's really most two sides of a coin. Yeah. So it's yeah, if you know how to send packets and receive packets, I mean that's really like the things that we need to do, and that's more maybe the boring things. That's all. Essentially, that's already demystified. That's how boring writing an MMO is. Essentially, it's just sending data, receiving it, unpacking it, reading it, parsing it, understanding it, and doing some stuff. That's essentially all, and that's what I want to get across. Actually, I mean it's like so that can be encouraging now or discouraging, but that's already all there is. It will not change so much essentially. I mean that's what we will do until we're finished. That might take months or years, but that's what we will do. Um, yeah, more or less. Um, Now we examine the incoming data. Yes, so we look at initial data on. Now let's do it a bit in a different way. Let's say the X cohort of the player itself, or let's say the X cohort of us. Okay, that's an ugly name, but I think it gets the point across. That's the X coordinate of our own player, and we know where that is. We know where that is. That is in that first byte. Then we have the Y cohort of us. I mean, maybe I will change it. let's be a bit more professional here. Let's call it the local player, okay? Because that's what it really is. That's really the local player. And of course, you could use a vector struct, you could use a vector class, and so on. But we are in prototype wild, freestyle wild mode, so we just don't do that now. Okay, and just for example's sake, we say the number of online players. Well, that's in initial data number two, index two. And just in case you don't remember, that's because we put it in here, and that's what I always call the protocol, because we say at the index two of that specific package, that's that's the number of players. And here we stuff it in, and we said it's two players, and that's why we send these four coordinates. Um, I think I actually sent six. Doesn't even make sense, but we just don't care. Yeah, because that's x and y of the first player, and that's x and y of the second player. Sorry, x and y, x and y. Yeah, so actually that doesn't even make sense. So the length is 7. Um, okay, if I'm if I'm doing crap, just tell me. But I think that's now more correct than before. Um, okay, and that's it. And so just to stop there now, then let's say the x coordinate of local player one, or for example, we could now say, okay, yeah, I mean, we could now, for example, we could allocate a dynamic array like a C++ vector, for example, yeah, and then say, okay, so now I know we have these number of players here. Like, I don't know, in an MMO, it might be, I don't know, 1,000. I don't know, it might be a big number. Then we might have a structure which we can iterate easier on. So we would not do it normally like I do it now, like xcord, like remote player one or something like that. I mean, I would not do that. But for now, let's just do it to get on with it. Okay. And yeah, I mean, let's just see how that works. And I think it will very probably not work. Um, but let's just do it. I think we learn more when we see things fail, and then we see how to hopefully solve the problem. I think that's more useful than to just kind of do it correct right away. Okay, compiling, running. So, I mean, I think we should be set up if I'm not completely stupid. Yeah, so let's just try. So the server is there, like waiting for packets. No client, okay, nothing. Game is dead. So we have to build the client to be sure. And so, bam, what is happening? Let's see. Let's close the client. Oh, let's have it open. Why not? Several things are happening, and it's like it happened what I expected. But let's do it step by step. So the first fact is, and let's just close the client down. I mean, it's still running, but we don't need it. Doesn't make a difference actually now. Server still runs. So what has happened is that the server started, and let's go to the server code so that we understand better what's happening. So the server started, and we entered into that loop, that endless server loop here. Okay. Eventually, the client came up, and before the client entered its main loop, we sent our magic message. Okay, and we know that that worked quite well because of two facts. Because first, we see here that now the data received is the 7, and overall the client sent 4 bytes. That's exactly what we did. And the first byte was a 7 because that's where we examined the first byte. And then after after that we like that's just for logging purpose. But then we really examined and we really kind of parsed the data, and then we say, and we know because we invented that, we say the message type, that's we just said that that's the first part. That's the first byte. So that message type, we made a switch over that and said, okay, if it's a 7, then we say it's a login message. And we see exactly that's where we came out. And here I forgot the break, but okay, it's the end anyway. So that worked. Okay. So we can assume that we also then call the send initial data to client message. We could do a logging to make that sure. I mean, let's maybe just do it, but to be sure that worked. And let's clean that up right away so there will be a break. Um, and go to that message here and let's say, okay, SDL log, like a trace message, like, okay, in send initial data to client. So let's just do that. So at least that's something that we should see. Okay, let's just run the client again. Okay, and you see the client, the same crap. I mean, like nothing happening. And there we just see, okay, well, it sends it to the client. But now that's the wonderful world of like asynchronous programming and like having two different processes here. So this process here, sorry, don't want to make you sick. And I hope you could even read that. Sorry, that was behind the chat. Um, this process is still running here now. Yeah. So I mean, let's have a look. Should see that here. Yeah, that's actually saying it. That's the name of the access. So that's server game X. And you see, because of my endless loop, that's 26%. Like that's quite a lot already. Yeah. So that's running definitely. And if I run the client again, that's also running. It should run. We should see somehow that there's the main game. Why don't we see that? And so now you see that I'm 100% CPU because I have two main loops running. So there is a lot of things running here. Yeah, and here it's the game exit. Yeah, because that's a separate window. So that's a separate process. So that's this thing here. So that's also running more or less on full steam, let's say. Okay. And here you see actually the window title. But you know this, I guess. But you see here we really have started up two processes here. To separate operating system processes. And what is happening, we are in the world of race conditions. So what I think is happening, I didn't prepare that now to to that point. So let's really see it, and I will try to solve this problem now uh, by some brute force actions actually. So what is happening, let's try to analyze this and let's put that out of the way. What is happening, let's go back to the client code, is that we are too quick, essentially. So between this here, this sending of packets to the server, even though we're on the local host, I assume, I mean, we will see. Maybe I'm wrong, and maybe I will have trouble to solve that right away, and I will have to maybe think about it over the night. But let's hope I'm right, because I think why we don't receive anything is that, whoops, we sent stuff out. Um, it takes physically takes some time to reach the server. The server takes physically some time to process the message, to go in his process space, to go into the function that sends the initial data back to the client. So it takes some time. It, I mean, it's horribly fast. It's blazingly fast, but it will take some time. It's like physics. That's Einstein. I mean, you cannot, I think, not walk back in time or something. Yeah, I mean, it will take some time, and it might take longer for the server to answer than it takes for the client to just move on. And I have a 4-core machine, so um, that's two processes. So that's very likely that one runs on one processor, one runs on a completely different processor, so they don't wait on each other. they are separate from each other. So this client sends this thing that's not blocking at all. Happily, it just continues the next command and the next command and the next command and the next command here. That's already the receiving. And if we are looking at the network card, essentially, if some bytes are there at that specific socket here, at that client socket, if we do that before the server has actually sent some data there, well, that's fine. I mean, we have seen that in the other stream, I think yesterday it was, that this is a non-blocking call. It just looks, it peeks. Is there any data on the network for that socket? Is it there? No. If there is no data because the server is still busy in doing our composing the initial data for us, and it might take some time in reality, even more than we have now. In our code now, it happily returns from this function call. UDP receive, there is nothing, okay? There is just nothing. And we just read data out. I mean, what I do, and I see I'm stupid, so maybe it will even work anyway right away because I'm not printing out anything of the data. So that also that might be that might be the problem. Actually, I will try that out. But please keep in mind, even if we now see a thing without me changing anything else, even if we see now something, all that I said is absolutely true. That it can really be the case. So that's one of the main issues of, or challenges, or whatever, of multi-threaded programming and of multi-process programming, of asynchronous programming. You always have these kind of race conditions. Okay, so let's try because we are on a local host, so it might even work. But let's see, or maybe it works one time and doesn't work the other because, yeah, sometimes we are slow enough, sometimes not. So let's see. Let's play it around maybe 2 or 3 times, and then let's see how we could solve that, hopefully in a naive way, if it does not work. So let's just say, what is the X chord of the local player? That's just one thing we are interested in. That's all. That's an integer, and we will just print that out. Okay. Okay. Yeah, let's try that out. Let's close that down. Let's go to the server can actually stay running. I mean, why not? I think it should work. Yeah, for the server, nothing has changed essentially. But we need to recompile the client and we need to have it run. And yeah, so the server still works. And okay, so it actually worked. I hope you still believe me because of the problem, because actually it might not work. I mean, I think because of the nature of the client, I have to start it again now. And then we can see if that works. Yeah, so that works now. Yeah, we could probably do something to kind of prove to you that there is a problem. Let's just try something out, and that's maybe like one of the last things, because you already saw that, I mean, our basic interactions is actually working. Yeah, but let's now spend some more minutes to try something out that might be interesting to learn, because that's one of the most important lessons that will always bite us, these kind of issues. Because let's now say there, let's say artificially that this method takes much longer. Let's say that this is a very expensive functionality that is running on the server. Okay, let's say that this runs, I don't know, for 5 seconds, which is quite a long time. I just have to look up the right command. um, I think it's, I think it's here. Yeah, I think it's STL delay or STL sleep or something. Yeah, okay. Yeah, okay. Exactly. This is what I want to do. I want to kind of artificially delay. That's exactly what I want to do. Delay my execution now by milliseconds. So that's 5,000 milliseconds if I want 5 seconds. Okay. So what should happen now? That normally I think that the client should be too fast for the server. Let's see if that is really the case. I hope so, because otherwise you will not believe me. I know. um, So we have to stop the server. We have to recompile the server again because we changed it. Now let it run. And now that's live. I assume, I hope I'm right, that the client will not show the X coordinate right away. Okay, it did. That's interesting. Why did it do that? Okay, I have to look that up. It should actually not. Um, Let's maybe because but I want to be sure that it really works in the way I intend it to work. Um, because we sent out that message when we reach into that method. So I want to send out, I want to really check that if that really takes 5 seconds. um, we just waited for 5 seconds. Now sending the package to the client, really. So let's build that again. So we are sure that we're doing that. So, okay. So we now have to watch closely. So what will happen is that, it will recognize that there's a message, it will go in, it will more or less immediately print that out, and then it should take 5 seconds until we see that. And then we know that we actually wait for 5 seconds. And I just want to see that. If it still works, then, well, anyway, I will accept that I understand something wrong probably, but let's just see. Okay, so that essentially looked right. Um, and I'm a bit confused now. I will actually try something out again. Sorry, just put that out of the way. Okay, but that's it looks really like it's immediately there. Um, that's actually interesting. I mean, there could be some weird things like because we are on the no, not on the virtual machine because we are on the same machine and um, that the memory is even still just there on the client. I mean, I think I will probably just accept it for now, yeah, because I'm really a bit tired today. But oops, sorry. But let's think that through once more. I'm actually a bit. I mean, I'm happy that it basically works. I mean that's good, but I am actually a bit surprised that it works in that way because normally I know that it works. That this should actually not work, and especially if I wait for 5 seconds before it's really sent. I mean, what could be the case is, I mean, what we could try out is to send actually some other value and to see, because maybe, because when you run a process and it's like there's not changing a lot. I mean, the memory is not so volatile, so it might be that in the overall memory that's just the same, and I mean, it can really be the case. So that when you look into that initial data zero, so that in the very specific memory space there was a place there was the value 3, which we sent. I think. I mean, is that even right? Let's see. It's even right. Um, yeah. And anyway, I mean, it's wrong as well. X coordinate local player 3. That's totally crap. I mean, that should be 50. Uh, okay, there's something going on. Okay, we have a problem. I mean, that's nice. I think we didn't have so many problems so far. It looked even like an MMO programming was easy. So now when we get into the real things, it's not so easy anymore. Um, so why is that happening now? Okay, so now I want to know it. What could be the problem is, I mean, there is for sure a problem because these are different dates, and I mean that's already a problem. Probably. Let's just quickly check this. Because, or I mean, that could already be the thing. Of course, I mean, because there is just something in there, yeah. And yeah, there's a third option. We'll come to that, but now let's just see if that if that makes sense. But I think I'm actually right. It just tricked my I just tricked myself into believing it was working, but I mean it was not working anyway. So let's start the server. Let's compile the client, and let's have a look. Okay, so that's okay. That's okay. And I think that is actually the problem, because if you think of it, um, what is happening here? Um, we are just stepping here through these commands. So we create a packet, we receive something, or we look something up from the packet. And what we should actually do is, and I did not do it now, but that's kind of stupid. Um, receive, okay, if you remember that back from yesterday, there STLNet actually gives us an information. No, Pickle, I don't think, or I'm actually quite sure that it does not block in the client. You are actually right when you say you just write the value of the uninitialized buffer. Yeah, we're absolutely right. That's what I wanted to get to, because I'm just writing out what is in the buffer, and this can be anything. Now it's just free, but it could be anything. Um, exactly. You don't even check the return. That's exactly what I want to do now, and that's why I just add the receive OK, because we should actually do it only if the receive OK is actually OK. Yeah. So that's actually, there were many problems here, and many bad things. So Pickle, you said that absolutely correct. Yeah. And I was just about to realize it. You realized it in the same moment, very probably even before myself. So kudos to you. Um, so we should really only get into there when we receive OK, and if not, and then we will have kind of like the proof. Then we will just write out STL log. Okay, nothing received from the server, because then for now we will just continue, but then we will have it written out. And I think the server can stay the same for now. We will just do that. Yep, and that's it, because now we will get something from the server. Okay, so now we have two options to solve that, or there are several options. One more elegant, and then some are not so elegant. For sure, we could now, for example, we could do some busy looping. Yeah, so we could say essentially while not receive OK. So as long as that's not OK, we will just try that, and we would probably pull that out, like we pull that out here, because that's only done once. I mean, that's actually chuck, chuck, chuck. While not receive OK, I mean essentially just receive again. So we'll pull that in. So we could do that. I will not do that now, because anyway that's busy waiting. I mean, sometimes you don't have any other chance, but yeah, normally we try to avoid that, because that really puts strain on the client. So well, what you could do for now, and it's just maybe even better uh, getting our point across, that we will now just artificially, um, and we'll just put that back in, because that's okay. We can just put that back in. Um, sorry, that was not good. Put that back in there. We will just wait for 10 seconds, for example, or 7 seconds. We will just wait longer artificially now. I mean, that's not realistic, but just for getting the point across, we'll just wait longer than we know that the server needs to answer. So you cannot do that in reality, because you will not know, but it's just for demonstration purpose now. So we will now do the same command here, and we will just say STL delay, let's say for 7,000 milliseconds. Okay, because that that should buy us enough time. Okay, so let's try that out. The server can stay, the client has to be rebuilt and has to be run. And now let's see. Ah, okay, so now it sleeps, so that's that's the other thing here. And nothing received. Okay, that's interesting. Okay, that's interesting. Yeah, but it's clear, of course. I mean, I'm stupid because I have to receive after the 7 seconds. I mean, that's clear. Otherwise, that doesn't make sense. But as you saw, um, we are getting into more kind of real things now. We are leaving a bit the toy land, a bit. I mean, we're still in super toy land, of course, but we are getting into a little bit more the real thing. So um, if you want, if you are doing a delay like on the main UI thread here, okay, well, it just the window completely freezes. So for example, that's what you do. So if you would do a busy loop, for example, in a real game, of course, you would very probably do that on a separate thread so that you don't have such a thing here. Yeah, because it essentially, if you have a busy thread, that might have the same effect that you just don't update the UI anymore. And so you would do that on a separate thread. Even if you do busy waiting, you don't do it on the same thread and so on. But I just don't want to open up a thread now. That's that's too much for now, but I'm afraid we have to do that anyway, sooner or later. Okay, just let's rebuild the wonderful client. Let's start it again. And it's so frozen, I cannot even move it. I'm very sorry, but as soon as the client server is done, well, it's still waiting, and voila, okay. And now you see all is now really correct. And so we have the 50 now, and I will just close it down so it's easier. Um, and it runs through in a clean way. So we have now the x coordinate of the local play. It's 50 because that's really what we expect. That's what we poked into the memory here. That was our data out in that function here. That's the 50. And essentially what I told you some minutes before, that's really what happened. I mean, that's really what the problem was. Um, let's quickly recap that because I think that's really, really important. That's really one of the core like issues that you have when you do this kind of programming. You are really not doing any more sequential programming in a single process where you more or less are very, very sure that, okay, for us human being, that's just easy to follow. Well, it does that, then it does that. And that can be complicated. We know if you did some programming for some time, you know that that can be complicated as well. But here we are in a completely different game. I mean, if you are really like doing asynchronous communication, well, yeah, things take their time, and here it's on the same machine. But if it's over the internet, you have the lag and you have the all the physical problems like like if that a physical cable has, and so on and so on. So you really don't know how long things take, and that's really the main takeaway of this thing. You just cannot write that naive sequential code anymore if you deal with these things. So like what we had before, we didn't have that. We just had a packet. We just said receive. Okay, we should have checked if something is there. Okay, we should have done that. Maybe we could have done that. But immediately, let's say we check if there is nothing. Okay, we just there is just nothing, and we just continue. Um, and that just doesn't work. I mean, it could even have worked, but yeah, it did not what I expected because yeah, that's just not the way things work. And okay, how we did it now, that was just for demonstration purpose. So I will leave that in the code for now, just to have it in like as a reminder. Um, and you would very probably do something else here, like a busy loop on a separate thread or something. But really, that's one of the main takeaways. This is really this is where you have to be careful. And I mean, now it was still rather easy to spot. And I mean, I kind of like I already expected it. I kind of knew it before. But if you can imagine, I mean, that's really baby stuff here. I mean, that's nothing. I mean, that's really like, yeah, just some lines of code, and it's really just to play around and demonstrate things how they could go. But if you really have a game with, I don't know, 10 thousands of lines of code, and there is really a lot of complicated interaction going on in each frame several times, between the client and the server on different channels and so on and so on. Yeah, so Like we might invent three, 10 channels which send data on a different frequency. Um, and then you hunt down a bug where you say, well, I mean, it works sometimes, but I don't know, each 2 times in a minute, I don't know, it seems that some packets are lost, or that the player jumps from left to right or whatever, that it seems that the position data is not coming in the right place or whatever. Well, then all these things have to be taken into consideration. Okay. Okay. I mean, at this point in time, I will save everything. Let's have a last look at our wonderful endless whiteboard. So what was our goal, and did we achieve it at least partially? I think we did actually. I hope I didn't promise too much. I think we achieved what we what we wanted to today. Okay, I wrote a lot of crap again. So what we wanted to do today was talk about the game state. We did that, and we wanted to exchange messages between the client and the server. So what we did, the client sent a magic byte to the server. We did that. That was the magic byte 7, and then the server answered, and the client like pulled out the data again and is now able to do something with it. And yeah, I think I will leave it at that for today. So as you see, we're getting more into, I hope, interesting territory. Um, so the question is, and maybe I will, yeah, I ask you, maybe you want to give me some feedback on how to continue, because I see basically two main directions now that we could go. We could stay a bit more focused on the server side and try to like concentrate more on the server loop and go into more interesting topics like how often do we send actually state. So now we send the initial state, but we need to obviously send state more often than once to have a game running. So we could more concentrate on the server side of things and flesh that out more and try to, yeah, optimize is the wrong word here, but like go into how would such a server work actually more in like a real life scenario. Or, which also might be interesting, and we might even see a bit of things on the screen. Like we more move now to the client side of things, but still have a networking in mind and actually render stuff that we receive from the server, and we go more into the direction and the problems of the lag, how to compensate the lag, how the differences are between the type of games, because there are types of games where okay there is a lag, but it's not a big problem because of the dynamic of the game. So the less frequent the actions of the game are, I mean, the less problem the lag is, of course, obviously. And the more like round based the character of the game is, the lag is not so important. I mean, it can still bite you, but it's not so important. The more real time the action of your game is, um, well, the lag can completely destroy any gameplay. Well, that's one of the reasons why, for example, the more classic MMOs, there is no real-time fighting in the MMOs of the mid and late or mid and early 2000s, or not to my knowledge at least. But that's all. But there's these round-based fights, which you might or might not like. But that's one of the reasons is because it's much easier on the network, and the whole network logic is much easier if you are not completely in real time handling all the things. So yeah, I mean, I will stay a bit in the chat, I guess, and yeah, the chat is also open when I'm not online, I think, or you can also leave me a message at Twitter or something. Um, so what does Pickle say? There aren't exactly game choices. I would have a goal that any player would understand, like moving around. Um, yeah, sure. We sure we can do that. The question is more, should we go more in the client or the server direction? Because I think it makes sense then to stay a bit on that, and we might spend more than one session on one of these directions, because we might now enter territory where I might talk less for one, and might code more, but I think we might reach the point where we yeah, we need more than one session for a specific topic because the topics are getting, of course, more involved and more complicated. Okay, but for sure, move a player around. That's probably the most basic thing that we need to achieve anyway. Yeah, that we need in almost any game. Yeah, so we could do that. We could do it more from the server, more from the client side, and that's just a question. So yeah, please think about it. Just leave a comment in the chat, and I will also think about it. Um, and we will just take a decision. So for the next stream, I'm not completely sure if I can make it tomorrow. Probably will only be after tomorrow, but I will announce it on Twitter and Twitch itself. Um, so I will let you know as soon as I know it, and I will tell you the time. When I can do the stream, then it will be again at 8 o'clock. Very 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 probably. But I will tell you the time when it is when it is happening. Okay, so I hope you had at least some enjoyment of our coding and discussions today. So yeah, thanks a lot to anyone watching, and also very special thanks to Pickle for all the interaction you provided and all the very good questions. And yeah, I hope to see all of you next time when we will move a step further in our adventure. Okay, so from Europe, have a nice evening, have a nice night, and hopefully see you very soon with our next steps here. Okay? Thanks a lot and bye bye.